All right, so 12.3 is applications of scientific notation. All right, so the very first type of questions you'll see is going to ask you to write numbers into scientific notation. So you might see some values that look like this: 63,900,000. To put something in scientific notation, you need to move the decimal place, which is actually located right here. And you're going to move it until it makes a number that's between 1 and 10. All right, so I'm going to go 1, 2, 3, 4, 5, 6, 7. So it took me 7 digits to move before I got a number that would be now between 1 and 10, because this is technically now 6.39. So 6.39. That number is now between 1 and 10. Don't worry about writing all the other zeros. But then to write this in scientific notation, you would simply say times 10, and then you just count how many times it took you to move. So again, that was 1, 2, 3, 4, 5, 6, 7. So that becomes 10 to the 7th power. Because what you would do here is, if you were to plug this into the calculator, you would figure out what 10 to the 7th power is, which is probably 10 million or something like that. And then when you multiply it to 6.39, it would make 63,900,000. So it's basically like a shorthand to write really big numbers, or on the flip side, really small numbers. Do notice when I was counting, I was going to the left. So if you're moving the decimal place to the left, it's going to be a positive exponent. And I say that because if I'm dealing with a really small decimal, like 0.1, 2, 3, 4, 5 zeros, and then 2, 4, 5. So this is actually 10, 100,000, 10,000, 100,000, millions, 10 million. This is actually 245 hundredth millionths. Really small number. But again, to shorthand it, I would move the decimal place until I get a number that's between 1 and 10. So that's going to be 1, 2, 3, 4, 5, 6. So my new number is now 2.45. And I would just simply still say times 10. But this time, since I went to the right, instead of it being 1, 2, 3, 4, 5, 6 as a positive, it'll actually be -6. Because what you're really doing is you're calling 10 0.000001 and multiplying it to 2.45 to make it that 0.00000025. Right? So if you have to move the decimal to the right, you're going to go -6. If you have to move it to the left, it's going to be positive. Or you can think of it, if it's a really big number, your exponent better be positive, and it's a really small number, your exponent better be a negative to represent big and small. All right, now from that, we can then take that and simplify these expressions. So you might be given things like this, where it's 2,600 times 0.0036 divided by 520,000. I guess that would make it easier. Personally, I would actually probably plug this straight into a calculator. But to show this how to do this by hand, what we're going to do is we're going to plug all of this into as scientific notation goes. Let's make this a little bit darker. Let's go. So 2,600 will be written how if you had to write it in scientific notation? How would you write 2,600 in scientific notation? Perfect. So again, I would have to move that decimal 3 times. Perfect. How would you write 0.0036? Mm-hmm. There you go. Perfect. And then how would I write 520,000? To the 5th power. Perfect. Now, what they say is now simplify this in the sense of, say this is 2.6 times 3.6 over 5.2. And then over here, you would write 10 cubed times 10 to the negative 3 over 10 to the 5th. This part we can simplify using our rules that we learned last week. This part, I'd probably just type into the calculator anyways. But if I had to simplify this, what do I do first on top? When I'm multiplying them, what do I do with their exponents? I'm going to add the exponents. Perfect. So I get 10 to the 0 power over 10 to the 5th. And then what would that become? What do I do when I divide? Subtract. So 0 minus 5 would give me -5. So I got this situation taken care of. Now I just have to figure out what this situation is. So in your little calculators, I saw a lot of y'all have them. What is 2.6 times 3.6? And then take that result and divide it by 5.2. So this part, I could use my exponent rules. So I added my exponents and then I subtracted them. This part, I'm actually just going to plug into the calculator. I mean, you could do it by hand, but what is it? 1.8. So this part becomes 1.8. And then you bring this part that you brought and you come back over here and you say times 10 to the negative 5th. So basically, you get to deal with small numbers versus having to deal with, 520,000 or something. What's your float? Make sure your float is on float and not like on 0 or anything. Yeah. Times 3.6. And then take that answer and divide it by 5.2. Yeah. Sometimes if you have a float like on 0 or 1 or something like that, basically you take all the decimals away. So good there. All right, let's look at another one. We have 108,000, 3,400 divided by 0.06 and 510. Now we got 2 on the bottom. Mm-hmm. This one is, I put that one in my bag. Yes, ma'am. 510. So how would I rewrite 108,000? Ooh. Ooh. Remember, it has to be between 1 and 10. Mm-hmm. 1.08 times 10 to the what? 5. So there'd be, so it's 1, 2, 3, 4, 5. So I'd have to move it 5 times to get that decimal to the 1 spot. Between 1 and 10. Same concept. Like up here, I still put the decimal so that I got 2.45. So here I would go 1, 2, 3, 4, 5, 6 and count that first number. Here I would count all the numbers and stop at the first number, basically. 1 and 10. Yeah, so this number has to be between 1 and 10. So 10.8 would not be between 1 and 10, so I couldn't use that. And so this would be then 10 to the 5th power. Oh, you're good. All you gotta do is basically just count the numbers to get to that decimal right there. So like for instance, 3,400 will be written how? 3.4 times 10 to the 3rd power, because you want to count that 4. So you'd be count the 0, that's 1, count the second 0, that's 2, count the 4th, that's 3. And then I would stop there because I want that decimal to be there. So this would be to the 3rd. And we're about 0.006. It has to be between 1 and 10, so it'd be 6. This 10? Oh, this I was just stating that this number had to be between 1 and 10. And this is a note. Perfect. So this would be, no, you're good. So this would be times 10. And yeah, so that because I moved it 3 times, it'd be -3 because I did go to the right. There it is. And then from that, we can simplify it by separating all these numbers. So I can say 1.08, 3.4, 6, and 5.1. And over here, I can take all these 10s. So 10 to the 5th, 10 to the 3rd, 10 to the -3rd, and 10 squared. All right. So now let's apply our exponent rules when it comes to these 10s. So what am I going to do to the top part? So 5 plus 3 would give me 8. All right. And then do the same thing to the bottom here. We have -3 plus 2, -1. And then what do I do with the exponents now? Subtract since I am dividing. So 8 minus -1 would give me what? Very good. So that becomes 8 plus 1, which is 9. So now I got that taken care of. So now all I got to do is plug this part in the calculator to get my answer. We'll use a 1.08 times 3.4. And then I would actually probably go ahead and do 6 times 5.1 and then divide those two. And one got a second. Mm-hmm. Okay, 3.672. 6 times 5.1. And then divide those two numbers. So it'll be the top divided by the bottom. So it'll be 3.672 divided by 30.6. Perfect. So you get the 0.12 times 10 to the 9th power, because that's what you calculate here. But this problem would be incorrect. Can anyone tell me why? Mm-mm. Negative. Where's the negative? So I'll be positive number. Okay, so basically meaning that that 0 that's between this 1 and 2, that number would not be between 1 and 10. So what would I have to do to the decimal to make it? I would have to move it to the right. So now that becomes 1.2, but if I went to the right, it becomes a negative. But how many times did I go to the right? Once. I just have to subtract 1 from that value now. And so now I get times 10 to the 8th power. So that's one way to try to trick you. Yeah. On the homework? Yeah. Yeah. But that will get you, because you'll do all the work and then you'll be like, I don't understand. But gotta make sure it's between the 1 and the 2. Or sorry, between 1 and 10. We good there? All right. So next thing we're going to do, you're going to have some word problems. This one says that 1 mole, a value often used in physics and chemistry, equals 6.02 times 10 to the 23rd power. This is what 1 mole is. Particles for all substance, and it's asking how many particles would be in 8 moles of carbon. So what it wants you to do is to take this and times it by 8. Now, this is a really big number, times 8. So what we can really do is just take these nice numbers here, and we're going to ignore the 10 to the 23 right now. So what is 6.02 times 8? What is it? 0.16 times 10 to the 23rd. But again, is this number correct? No. What do I have to do? To the left. And if I move it to the left, what am I going to do with this exponent? Remember, if I go to the left, it was positive. So I'd actually add 1. So in this case, this becomes 4.816 times 10 to the 24th power. And so using some of these techniques avoids us basically multiplying by a really giant number and having another really giant number. You still have 1, but it doesn't look like a giant number. It looks like a normal, decent number. No, that's it. That's all there is to it. Say one more. So I am so sorry. I got distracted. Yes. So I ignored the 1023 and just let it ride, because that number 10 to the 23, I can't even fathom how big that is. I mean, 10 to the 23, that's basically 23 zeros. I don't even know what number that would be. So I don't want to multiply that. That looks like a really big number. So I'm just, since it's all being multiplied, I'm just going to multiply by these regular numbers, 6.02 and 8, and then just apply it there. All right, so the rest of this is basically just kind of showing you how to use the calculator. And I'm going to be honest, I am having difficulties with my calculator and I do not know why. But maybe it'll work today. Who knows? I've been trying different internets. And I can't tell if it is my computer or if it is some other computer. Yep. 3 was a word problem. It basically said, hey, a mole is equal to this. How many is 8 of them? So you just multiply by 8. Yeah. So basically 8 moles weighs this much, whatever that is. Yeah. That many moles. Yeah. Now to use a calculator, see if I can, again, I've been having difficulty since Sunday. See what it says today. Yeah, I keep getting this one. I've already emailed both TI and then my school, and I just don't know why I can't pull up a calculator. Yeah. I don't have any other calculator applications to show. Let's see. I guess really and truly, does anyone have questions on how to type this into a calculator? So I would start, y'all look like you have 84s. I would, no, you're good. In fact, wouldn't be able to, I don't have an Elmo with me either. Best of, yeah. So when you do this in your calculator, the key here is to make sure everything's in parentheses. So you're kind of indicating, hey, calculator, I want you to multiply this first, then I want you to divide by this result. Kind of like what you were doing on your phone, right? Oh, I don't know, because a lot of times you'll just get an E. So normal calculators will just give you an E. Does it not give you an E? Did they give you a number E than a number? Ooh. Yes, ma'am. Mm-hmm. Now divide that by 0.032. Ooh, let's see. So it multiplied and then divide. It says error. Let's go to the syntax error. Oh, it doesn't do commas.
Oh, okay.
Yeah. So your 84s do not do commas. So you would type it without the commas. So 70,000 is all we got. All right. So if you don't have a scientific mode that would calculate it for you, which is kind of nice. That's fine. Make sure you multiply first, take that result and divide it. But regardless of which direction you went, we all got, is it 7,000 or 70? Gotcha. Did you get that result? Yeah, 7 times 10. Not in this case. Mm-mm. Oh, you did. Oh, you did this by hand. Oh, okay. So if you did it, technically the book's having you do it in the calculator. But if you did it by hand, you would have got 4 times 10 to the 6th power. And this would be 5.6 times 10 to the 1, 2, 3, 4, negative 4. Yeah. Because I would go 1, 2, 3, 4. I would only move it 4 to the right. And then this one would be 3.2 times 10 to the negative 2. Yeah. Regardless of which way you did it, if you did it by hand or by calculator, this is still the incorrect answer because now I got to convert this into scientific notation. So what would this become? Not to the right, to the left. Uh-huh. So how would I write it? Perfect. So those sevens between 1 and 10, which is great, times 10, and I had to move the decimal 4 times to the left. Oh, what do you mean? Oh, in the homework, it's going to tell you, please write your answer in scientific notation. Technically, 70,000 is a correct answer, but it's not scientific notation. Has to be a number between 1 and 10 times 10 to some power, whatever it ends up being. That's a good question. Because, yeah, technically, if this was a word problem or something that we worked on a previous chapter and 70,000 was our answer, we would say 70,000, right? But in this section, it's practicing scientific notation. All right, so try this one real quick. And it has actually a mixture of both. So you can approach it with either by the calculator or by hand, whatever you're comfortable with. You're good? You trying to convert this back to 70,000? So you would say 7 times, that's what this X is. It's not the letter X, but a multiplication. 10 raised to the 4th power. It should pop right back out as 70,000. That's a great way to check it too. All right, so if you want to do this by hand, I would convert this as well. So what would this become? Perfect. So basically what we do is we're going to look at the tens. So I'm going to rewrite this so that this is 5.4 times 5 over 4.5. That part I'll type into the calculator. But with these tens, I would say 10 to the 4th, 10 to the 3rd, over 10 to the negative 5th. So I kind of separate to do it by hand so that I can add these two values. So 4 plus 3 would give me 7. And then when I do this, I would do 7 minus negative 5. 12. Good. So I have that taken care of. And now all I have to do is plug this in. So I'd say, all right, what's 5.4 times 5? Take that answer and divide it by 4.5. So no, that's all right. So here's my original decimal right here. 1, and then 2, and then 3, and then 4, because that would be what makes it between 1 and 10. So I moved it 4 times. So that's basically what that exponent's telling me how many times I have to move the decimal. It'll always be times 10. That part doesn't change. The only thing that changes is positive if I went to the left, negative if I went to the right. And then, of course, the number between 1 and 10. Yeah. Yeah. So a lot of students, too, instead of moving the decimal, they'll just count the numbers. So 1, 2, 3, 4 numbers to get it to that between 1 and 10 works just as fine. Yeah. The E is actually times 10. Mm-hmm. And the last digit past the E would be the number that goes as the exponent. So if I was to get I don't know, if I would have gotten for this one here 7E4, that basically is what this means. This right here is times 10, and that 4 would go as the exponent. So if your calculator pops up that's basically what it's doing. Oh, is this what this is? Is 6? Yeah. So 6 times 10 to the 12th power. Mm-hmm. Times 5 would be 27. And then you divide that by 4.5, and that would be 9, 18. Yeah, 6. Yeah. No, I agree. I would probably just do it. Mm-hmm. 27. So then I got to take 27 divided by 4.5. Correct. Correct. Okay. Last problem on this section, and this is number 5. It's another word problem. It says if light travels at 3 times 10 to the 8th power meters per second. So this is meters per second. How many meters do light travel in 1 day? So I basically want to convert this to meters per day. Right? And the best way to approach this is to ask yourself, all right, well, how many seconds are in a minute? So, all right, so there's 60 seconds in a minute. How many minutes are in an hour? So I want to say 60. So basically what I'm doing is I convert it to minutes, not convert it to hours. How many hours are in a day? 24. And the best approach, if you're trying to do this by hand, is I would do 3, skip this 10 to the 8, and do times 60 times 60 times 24 and see what you get. Ooh. Oh, did you apply the 10 to the 8? Okay, so you got the final answer. I'll probably catch up with you here in just a second. Oh. Yeah, if you do, that's perfect. You could do that. No. You could definitely use the calculator here. It actually recommends to use the calculator here. I was just saying if you're trying to avoid the calculator, multiply everything but the 10 to the 8, and then you can apply. But then, so now take that answer and let's see if you can write it correctly. Times 60. Take that result times 60. And then take that result times 24. Yeah. Parentheses indicates multiplication, or you can use the times button. Yeah. I know it does. It says a lot of times if I don't put a times or parentheses, kids will be like 60 and then another 60, and the calculator is like, oh, 6,060. It doesn't recognize that needs to be multiplication. Oh, and the Alex. Oh, not Alex, Hawks. So yeah, so you would and just ignore the 10 to the 8th for right now. Absolutely. So take that and then now I'll reapply the 10 to the 8th. And so now this is wrong. So what do I have to do to fix it? Because I want the number to be between 1 and 10. So I want to go 1, 2, 3, 4, 5 numbers over. So now I get 2.592 times 10. Well, if I went to the left 5, what do I have to do with this 8? I went to the left. So I want to add. So now that becomes 8 plus 5, which is 13. 13. Right? Yeah. And so that would be the answer. You're good. So if you take the decimal and you move it to the left, you're taking a really big number and you're making it smaller. So that's why it wants to be positive, so that when I re-multiply it back out, it remains big. If I make that number a negative, now I'm going to end up with a small number. Why didn't I stop at this one, 9 and 2? Because then that would give me 259.2. The number has to be between 1 and 10. Yeah, so this number right here has to be between 1 and 10. So if I would have stopped right here, now the number is 259.2, and that's not correct. So that's why I kept going and stopped here, because now I finally got my first number that is between 1 and 10. So good there? Absolutely. That's fine. We good? All right. Let's take a 5-minute recess.